Problem number 13. So we're given a trig equation that has two solutions located in the interval 0 to 2 pi. In other words, we're looking for two different angles in that interval. We're going to solve the equation by drawing some reference triangle pictures and thinking about quadrants. We're doing the whole thing by hand and giving the answer in radians. So take a look at the first one. Sine x equals 1/2. X is the angle. 1/2 is the ratio. Well, if I have a positive ratio for sine, I can use my all students take calculus device to realize that a positive sine ratio only happens in quadrants 1 or 2. So it's possible that there's a solution here in quadrant 1. If the sine ratio is 1/2, there would be my picture. This is a picture we've drawn a zillion times. This angle is 30 degrees, which means one possible answer in radians would be pi over 6. But you see there's another symmetrical answer over here in the second quadrant. Same basic picture, opposite over hypotenuse, same reference angle, but of course now the angle I'm looking for is this second quadrant angle. 180 minus 30 would be 150 degrees, which in radians would be 5 pi over 6. There's my two solutions. Problem B. Now I have a cosine ratio. Where is cosine positive? All students take calculus. Aha, it's quadrants 1 and 4 where cosine comes out positive. So I'll be drawing one picture here. Cosine adjacent over hypotenuse. This is a 45, 45, 90 triangle, which means one answer is 45 degrees, pi over 4. Or I could have an answer in the fourth quadrant, cosine adjacent over hypotenuse, another 45, 45, 90. This time though, the 45 is just the reference angle. I'm looking for that positive angle. Remember, we needed angles only between 0 and 2 pi that lands at that spot. That would be 315 degrees, which we call in radians 7 pi over 4. Problem number 14. Make a list of 5 angles that would make this equation true. I think we could find lots of them. Of course, when I see a 0 with sine or cosine, I'm thinking unit circle. Sine represents the b coordinate. Well, here would be a spot with a b coordinate of 0, and here's the only other spot with a b coordinate of 0. So any angles that go with those two spots would work. So I could do 0 radians, I could do pi, I could spin around once to 2 pi, I could go in the negative direction to negative pi, I could spin around 1.5 times, right? And after a while you realize, look, any multiple of pi would be a perfectly fine answer. And then problem 15 is kind of like that number 13. We're looking for two solutions again in the interval 0 to 2 pi. It's just that this time we're not going to be able to do the work by hand. We're going to have to rely on the calculator a little bit. We are looking for approximate degree answers this time. So I have sine x equals 1/3. It's a positive sine ratio. So just like before, I know that I have to then be in quadrants 1 or 2. Those are the only quadrants where the sine function comes out positive. I'll draw my first picture in quadrant 1. Opposite over hypotenuse. This is not one of our special triangles, so I don't have any way to do this by hand, but in the first quadrant, I am in the zone for the sine inverse function. So if I want to know what this is, this little x right here, I would just have to type in sine inverse of 1/3. Throw in the ratio, and the sine inverse function will tell me the first quadrant angle that goes with that ratio. Okay, I am in degree mode, which is what I want. And so I'll go sine inverse 1/3, and to one decimal place, that's about 19.5 degrees. So we'll say approximately 19.5 degrees. Now that's one of my two answers. We already decided that there's another answer in the second quadrant. And see, of course, the thing is, it's going to be very symmetrical. Here's still a 1, here's still a 3. This is the same triangle that we just drew. Now here's the thing. I can't use the sine inverse function to find that red angle because that red angle is past 90 degrees and sine inverse has never heard of angles past 90 degrees. What I can do though is use the symmetry of the picture. This little angle here is the same obviously as this little angle here. It's the same triangle. And we already figured out that that was 19.5 degrees. Well, to get the angle I want then, I would just have to take 180 and subtract the 19.5. And that would give me this missing angle. Just to make sure I don't lose any digits, I'll do 180 minus that last answer, and that gives me 160.5 degrees. Well, that is another possible answer to this equation. Sine of about 19.5 makes a ratio of 1/3. Sine of about 160.5 degrees also makes a ratio of 1/3.